Hello, everyone. This is Dr. Li Chen at the University of the District of Columbia. Today, we're going to give a lecture on the Master Theorem in algorithms. This theorem is quite useful for analyzing many algorithms, but it is relatively hard to prove. I'm going to use maybe 45 minutes to 1 hour to show all three cases of the algorithm. These lecture notes were modified based on Brown University's notes. Let's get it started. First, we use merge sort as an introductory example. Merge sort is a sorting algorithm that arranges a set of numbers into an ascending or descending order. Most students already know that this algorithm reaches the minimum time complexity, that is n log n. Let's say that if we have an original array S, let me get to the pen, choose a color. We have original array S. We wanted to split the array into two parts. The first part and the second part. After we got two parts, we want to sort the first part, then sort the second part. After that, we do the merge. Let's assume the entire process for the array S takes T of n time. Then this step for sorting the first part would be n divided by 2. The same thing for the second part, T of n divided by 2. We can assume the merge time is O(n), which is C times n. Then what can we get? We get this equation. This equation shows us T of n equals 2Tn over 2, because we have two merge sorts for the half of the array. Then we add the merge time. After the calculation, we can get and log n. Now, here is the question we will have. What about if we want to divide the original array into 3 parts or 4 parts? What would be the recurrence equation? And what would be the solution of the recurrence equation? We can move down a little bit to write this equation in general form. Tfn equals a t n divided by k. That means we split into k parts plus, we don't know, it is linear, not linear. So we use Fn to represent. So that's the reason we want to have something called the Master Theorem that can give us the answer for the general divide and conquer problem. Okay. So the merge sort is a typical divide and conquer example. Now, the following is the general consideration. That is why it is called the Master Theorem. This general consideration, let Tn to be A times T of n over B plus Fn. This formula is even more general than the one we just did. If n is greater than or equal to D, and the D usually it's B. In that sense, if D is smaller than B, we have no way to divide it into B components. So if n is smaller than B, and we will not do the divide, we got C as the constant. Now, let's go through each statement of this theorem. First, we can do a little bit of explanation of the notation. Big O here means at most. Big theta means exact with regarding to a little c here. Big omega means at least. The first statement says if Fn is a little bit smaller than n to the power of log BA, we use minus epsilon. Epsilon is greater than 0, very small number. Okay, let me repeat. If Fn is O n to the power of log BA minus epsilon, then TFN will be exactly n to the power of log BA. Second, if Fn is exactly n log BA without epsilon, then n TFN is exactly n log BA log n. This is the one we have seen in merge sort. The third statement of the theorem says if Fn is at least n log BA, we represented that as n log BA plus positive sigma, epsilon, excuse me. Then TFN will be just Fn. Fn dominates the time needed for the algorithm of divide and conquer. Now, I like to explain to you a little bit of B and A. If A and B are equivalent, then log BA will be just 1. Okay, you can prove it and by the definition. So in this case, we ignore that. The exponent it's just 1. There are some cases A and B are not equal. Here is an example. We have Tn equals T of n over 2 plus 1 or plus C. This one we have seen that in data structure, which is binary search. The reason for that, I have put here. I don't have enough time to explain to you in details. You can read it. TFN will be exactly log n.